the total rainfall in millimeters and the total sunshine in hours at Valencia, County Kerry, or Valentia, County Kerry, during the months of June from 2001 to 2010. So that is 1, 2, 3, 4, 5, 6, 7. That's 10 data points, okay? Now, step one, your smallest rainfall, your largest rainfall, take away your smallest rainfall. Did anybody get 155 take away 47? What'd you get for that? 108 millimeters. Okay, next one. The June with the highest rainfall. Which June did it rain the most? 2003. The year with the least sunshine? Huh? 2002. All right, not bad. Okay. Based on the data in the table, write down the year in which you think was the best weather and give a reason for it. Which year do you think had the best weather? What? Most sunshine with the least amount of rain. All right. Could somebody argue that that's not good weather? Yeah, good weather is subjective. Somebody could like if it rains. If you're a vegetable farmer, you could argue that a mixture of both sunshine and rain would be more conducive to farming than. So you can make an argument, but in general, the general trend, what you're meant to say is that everybody loves sunny weather, and sunny weather is better for this, right? So that's what you're meant to say. So what do you say, 2006, because it had the most sun and least amount of rainfall. Yep. Right, let's drive on. A and B were handy, weren't they? So it's worth 60 marks, and you're probably on about 10 or 15 already. Write the rainfall data in increasing order. So let's write the rain data, which is all this data here. Start at the smallest and go all the way up to the largest. Okay, who's got me on this one? Yeah, 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 yeah. Okay. How many of these is there? 10. 10 is an even number. Even numbers, generally speaking, have a center 1 or a center 2. Center 2. Who are the center 2? Yeah, divide 10 by 2, you get 5, round up to the fifth and the sixth. So fifth and sixth are 94 and 101. And what do we get when we average the two of them? Yeah, 97.5. Okay. Yeah, 97.5. Happy days. Okay. Millimeters. Keep remembering that. Right. D. Find the mean number of sunshine hours. Right. So we've got to calculate the mean. So realistically, what you should do in your leaving cert is you already said you have plenty of time to get this done, didn't you? Or some you said you had anyway, right? So the fact that you have tons of time to do this means you should really write down your workings, right? So this is all that's all the sunshine, isn't it? So you're going to copy in here. I'm going to paste it. You don't have this luxury, unfortunately. You're going to add them all together. And when you add them all together, 1,800 and, yeah, and then divided by 10, is it? Yeah. So just tell me one more time. 1,800 and, yeah, and that's 18 point, what? Oh, 181.8 hours. HR. You all got that? Right. Wrong question D, and it's handy. Amount of marks we're raking up here, okay? Now, now this one's interesting, all right? So, you see your 181.8. What we're going to do is we're going to get 5% of it. So we're going to do 181.8, and we're going to multiply it by 5%. Okay? And we're going to get 9.09. Is that okay? Now here's what we're going to do with that 9.09. We're going to take it away and add it on to 181.8. So we're going to do our answer plus 181.8. So the upper part will be 190.889. And what's the lower part when you take it away? So I'm just making sure I did the... Yeah. That's the answer, yeah. Yeah, 9.09. Yeah. Yeah, 172.71. Okay. Now, how many days were in between this data? Let's find out. So we're looking for the number of days in between 170, roughly 173 to 190, because 191 would be too big, wouldn't it? 173 to 190. 1, 2, where's the other one? 180. That was 3 years there? Yeah. 2003, 4, and 5. And it says name them. Did anybody not name them and just said 3 years? If you did, you just need to read the question, right? Standard deviation of rainfall. Let's do that. Okay, so I'm going to find my rainfall data, which is this one here. Right, everybody take out your Casio calculator. Okay, and we're going to do standard deviation now, okay? What does standard deviation mean again? Does anybody tell me? Yeah, how close they are to the mean, basically. How close is each day to replicating the exact same amount? Great. And standard deviation is only good when you're comparing two sets of data to each other, really. Okay, it doesn't really mean anything on its own. But when you're comparing two sets of data, it means stuff. So. All right, who knows the procedure? What you do? No, you don't. That's the average. We already did that. You go to stat mode, 2. How many types of data? Do I have 2 types of data or 1 type of data? One type. One type. So we click number 1, don't we? Let's enter in all our data. Okay. And what's it, 94 and 84? We go with that? All good. What do I press next? I press AC usually, but I'm sure you can press option directly. And option, and you press one variable. Does anybody have the older calculator? Who's got the older calculator? For those of you on the older calculator, press shift and the number 1 to activate stat mode. And we can see that the standard deviation is 33.46 or 33.5. Anybody else get 33.5? Did that work for you, the people on the older calculator? For the old schoolers, okay? What we're going to do is we're going to go met modes, stat, 1 variable, and we're going to lob in the numbers. Oh, it'd help if I actually press equals. 101, 94, 47, 149. What's the other one? 134, 94, 84. We cool with that? Okay, press the AC button. Disappears, right? Now, see the yellow word stat over the number 1. Go shift to activate the yellow buttons. Press stat. And you see number 4, option 4? Option 4 is variables. Okay. Option 2 is the average, and option 3 is the standard deviation. 33.5. All good. Let's drive on. Okay, scatter plot. Yep, yep. Okay, scatter plot. Now, I might show you. I might show you a little trick here as well if you aren't sure about the scatter plot. If you have time, more of an honors level trick, but we can do it here ourselves, all right? I don't really. I am not sure. Is there a trend because of that outlier? It's only four pot. Is it? Oh wait. Oh, I get it now. It's not complete. Perfect. Right. So I'm gonna have to go back and find all the data, am I? We're gonna go back a page or two, and we're gonna draw in the rest of the points. So what year it is doesn't matter. So it's rainfall on top and sunshine on the bottom. Okay, I'll take these numbers here. Perfect. Okay, I'm gonna take. I have to complete the scatter plot. Okay, here we go. Sunshine, rainfall is the x value, and sunshine is the value. All right, 72 is roughly here, and 169 is roughly there. So that one's already done. Uh, they did the first four, did they? And then they did the first couple of years, did they? Yeah, that's 173 and 100. Yeah, they've done the first 4 years. Now I'm gonna keep going. 94 here, and roughly what's it? 100 and again, yeah. So it's about there, yeah. Next one, 47 and 240. 47 is around there. 240 or 239, about there, yeah. Next one after that, 150 and 160 roughly. So, sorry, what's a 149, which is 159, about there. Okay. Next one after that, 134 and 168. So 134 around here and 168 about there. Okay. And then finally 94 and 228. Yeah, 94 and 228. About there-ish. And 205 and 84. 205 somewhere around here, and 84 somewhere around here. Okay, what type of correlation are we looking at here? The more sunshine you have, the less rainfall you have, or the more rainfall you have, the less. This is actually a negative correlation. As one of them gets bigger, the other one gets smaller. So that's a classic example we could use. We can rule out the two positive ones straight away, can't we? Is there a correlation between sunshine and rain? There is. So we can get rid of that one straight away. So what's the only one left? Yeah. Escalation slope is negative. So what does that mean? Slope is negative, has to be. And then what's the other? And then what's the reason why we didn't pick negative 0.1? There is a correlation between sunshine and rain. Is that okay with you guys? All right. Volume. Sphere. Look up 4 over 3 pi r cubed, yeah? Lob it in. We cool with that? What do we get? You've done already, do you? What you get? 0.113 centimeters cubed. All right, excellent. Everybody happy? Identify the formula, put in the formula, use your calculator. Okay. The sphere is made up of pure gold. So 1 centimeter cubed equals 19.3 grams. Is our sphere lighter or heavier than 19.3 grams? Why is it lighter? 0.113. Ah, so you should have used the volume. Dan, that's all right. And we get 2.18 to 2 decimal places, 2.18 grams. Right with that? Now, ooh, okay, this is not great, right? If you ever see this part here, do you see this thing here? If you ever see something like that, what's the only thing you need to worry about? How to put your calculator into science mode. That is the only thing you need to worry about. Does everybody know how to put your calculator into science mode? Here's how you do it. You go to menu or modes. Oh, sorry, you go to setup, shift setup. And do you see as opposite normal is science? Press science and just press 0. Is that okay, you guys? Now, what does it want from us? So 197 grams of gold has this many atoms. Is that okay with you guys? Do we have more atoms or less atoms than that? Less, don't we? Because we only have 2 point. Yeah, exactly. So what we're going to find out is how many times 2.18 divides into 197. So we get our 197 and we divide it by 2.18. And what we realize is that, crap, I was going to take myself out of science mode for a sec. See 90.36? We're 90 times smaller. Does that make sense to you guys? We're 90.366 times smaller. So you have to divide by 90.367. What'd you say? I did 197 divided by 2.18, and I found out that we're 90 times smaller. You get what I'm saying? So that means we have 90 times less atoms. So all I'm going to do is I'm going to grab that number, the 6.02 multiplied by what's it, 10 to the power 23. And I'm going to divide that number by. You're probably wondering why I got a funny thing there. I'm still in stat mode, so I'm just going to go to mode comp and try this again. 6.02 multiplied by 10, 23, right? That going divided by 90.367. That's my answer. 6.6610 to the. Oh, only wants two significant figures. So I'd have to put that at 6.7. 6.7 by 10 to the power of 21. All right, you guys? Just make yourselves 90 times smaller because you haven't. That's it. Get back into your calculator by going shift, setup, and go back to normal modes and go to normal 1. Cool. Yeah. Oh, Savage, one of these. And this is the last part, is it? Is it? Grant. It is. Oh, this is handy. Right, won't be long. Right. Margin of error, anybody? We did one of these yesterday. 1 over the square root of n. What's 1 over the square root of n? 1 divided by the square root of. Yeah. And it wants it as a percentage, so we're going to multiply that by 100 because it wants it as a percentage. And it wants it to 1 decimal place. And we got 2.5. Okay. Now, it wants the 95% confidence interval. So we're going to add and subtract our margin of error. Okay. Now, what's 546 divided by 1560? Then we multiply that by 100 to figure out what percentage of people like the show. Huh? 35. And let's take away the 2.5 and add on the 2.5. So through 2.5% all the way up to 37.5%. Is that cool with you? Now, yeah, still on it. See the word hypothesis test? Does everybody know what that means? What's H0? H0 is the claim what they're saying is true. What's H1? What? The percentage of people who like the show is not 40%. All good. H0 means what they're claiming is true. H1 is what they're claiming is not true, basically. Okay. Which one do we use and why? Do you see 40% anywhere in this confidence interval? Is 40% within that? No. So what does that mean? Reject their claim and accept H1. But you have to write that down. You have to use proper language. 40% is not in the confidence interval. So we reject H0 and accept H1. This means the percentage, I can just basically copy and paste this. Look at that, beautiful. Right, is not within the confidence interval. Good man. You're dead right about that. Is that the last question, is it? Done. Are we done?